Hi everybody, and welcome back to this video, the third one where we're talking about the SCR calculation. So we talked about SCR calculation at a high level, whether or not you use a standard formula or an internal model to calculate your SCR. And then we've talked a little bit about how the standard formula works, so how you're given numbers for the different shocks that apply for different risks. You apply those numbers to a formula to give yourself a number for each of those different risks, and then you combine all those separate numbers together via a number of different correlation formulae that eventually all kind of come together and give you a single final number for your SCR. Now there are problems with this kind of standard formula approach, so I'm just going to kind of capture three of them here. So this section is problems with this approach. So first of all, the standard formula is a formula, comma, and so may miss risks the company is exposed to. Whereas if you were doing an internal model and there was a significant risk to the company, then you would capture that within the model. So that's a downside of the standard formula, that it may miss things. And also, just because you're following a set of rules, you might not think about risk as widely or in as much detail as perhaps you should, or to the extent that it's good for the company for you to do that. Another issue is that the prescribed, so basically that means what you're told to do, so the prescribed 99.5% shocks may not be accurate. So for instance, that 99.5% shock for equities in stable market conditions was 39%. Is that accurate? Should it be 39%? Should it be 30%? Should it be 45%? What's your analysis of the data? What conclusion do you come to? You might come to a different conclusion compared to what the regulations are telling you to do. You might disagree with the regulations. You might think that for some shock somewhere the regulations are not accurate and significantly not accurate, but you have to do what the regulations say because you're following the standard formula. I guess it's maybe worth saying that one thing that is good about the standard formula is that everybody's doing the same thing. You know, suppose every company followed the standard formula, then the results mean that a comparison between solvency of different companies is arguably fair because everybody's doing the same thing. But then I guess you could argue in the other way that actually it's not as good as the internal model because, again, you might be missing things that are unique to a particular company. So you could argue that an internal model should be more accurate. Anyway, that's just a bit of an aside, a bit of the contents of my brain. Let's do one more of these. So this is about the correlation formula or formulae. So the formulae used to combine the SCR contributions for different risks have no or little theoretical basis. So what do I mean by that? Well, basically the kind of correlation formulae you'll recognize from the kind of standard formula for standard formula, that's bad choice of words, from the kind of formula for the variance of two rounded variables. So for random variables vary, oh dear, can't spell, variables x and y v of x plus y. So in this case, for my v means variance of rather than value of. So I appreciate I've used v for different things in the past, or a different thing in the past. So v of x plus y is equal to v of x plus v of y plus 2 times covariance of x with y. Okay, so we know that that should be kind of familiar to you from probability, but the value at risk, 99.5% point, is not equal to, or not necessarily equal to, value at risk 99.5% of x squared plus value at risk 99.5% of y squared plus 2 times value at risk 99.5% of x times value at risk 99.5% of y. Sorry, this should have an x plus y in there. Just thinking, should I have, yeah, let's put in, how will I do it? Let's put the square root in. So basically what the correlation formulae are doing in the standard formula is treating all of these value at risks as if they are standard deviations, i.e. square root of the variance. And that is just not true. Not equals is true here. So if you like, the entire Solvency II standard formula construction is made up, is made up in some sense. It's just not true. And this is an inaccuracy. Now, the counter argument to this is, well, what else would you do? You know, you're trying to come up with a standard formula. You're trying to combine all of these risks in some sense. You need some way of doing that all of the different insurance companies can follow. You need it to be as simple as possible. So if you like, this is a simplification that we choose to use. And in some sense, it behaves how you would want it to behave. So depending on how you change this number 2 down here, you can, to some extent, change the extent to which different risks are correlated together, and so make this number bigger or smaller depending on whether you think that 2 risks will behave in the same way, so they're 100% correlated, or whether they will behave in a slightly different way if they are less correlated. However, all of that doesn't get away from the fact that generally, theoretically, there is a not equal to sign here rather than an equal to sign. So yes, so a number of problems with the kind of standard formula type approach, but at least we are doing something, and what we are doing does take account of risk and the way in which the risks interact. And fundamentally, if we take on more risk, then the standard formula result gets bigger, and if we take on less risk, then the standard formula result gets smaller. And that's really the kind of result that we want. We're trying to make sure that companies are incentivized to think about risk and take less risk if they can do. Okay, let's finish this video here, and we'll come on to other Solvency II information when we do the next lecture.